2-6 is about combining functions. We'll be adding, subtracting, multiplying, and dividing these functions, and also something called composition. So given two functions, f of x and g of x, their sum, f plus b is a function, g is a function whose value at x is f of x plus g of x. F minus g at x is f of x minus g of x. F times g is a function defined at x is equal to f of x times g of x. And f over g of x is defined as f of x divided by g of x. These are all defined where they where both f and g are defined. So they're intersecting domains. In addition, for dividing by g, we have to specify that g is not equal to 0, or not a line division by 0. That's adding, subtracting, multiplying, and dividing functions. To compose a function, you get this thing denoted f of g. This little O means of. I know it looks like it reads fog. Its definition is that f of g of x is f of the quantity, g of the quantity, x. So you apply g, take x, apply g to it, apply f to the result. So, for example, 2 over x for f, and 4 over x plus 4 for g. What's their sum? What's their difference? What's their product? What's their quotient? Okay. Their sum, 2 over x plus 4 over x plus 4. This is defined where both of these are defined, namely x not 0 or negative 4. Oh dear, I see now that I messed up a small problem. This is page 6, page 2, f minus g. Oh dear, 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 dear me. All right, I shall have to fix this in the canvas. This should be a minus and this a minus. Okay, f times g of x is 2 over x times 4 over x plus 4. And you multiply that to 8 over x times x plus 4. All these are for x equal not 0 or negative 4. And f over g of x is 2 over x divided by 4 over x plus 4. We flip this upside down and multiply 2 times x plus 4 over 4x. We can do some cancellation, no big deal. And again, for x equals 0 or negative 4, and we don't have the denominator not equaling 0 because this is never 0. Here they ask for the domain of absolute of square root of x plus square root of 1 minus x. Well, it's the intersection of the domain of root x, which is where x at least 0, of a root of 1 minus x, which is where 1 minus x is at least 0. You put it together, it means that x is between 0 and 1. Now here we have some composition issues. F of x equals 3x minus 5, g of x is 2 minus x squared. What's f of g of 0? What's g of f of 0? Well, here we go. F of g of 0, well, f of g of 0 is 2 minus 0 squared, that's 2. F of 2, plug in here, 3 times 2 minus 5 makes a 1. Whereas g of f of 0, well, g of f of 0 is 3 times 0 minus 5 is negative 5. G of negative 5 is 2 minus 5 squared. That's negative 23. Notice that they are not the same. F of g and g of x are generally not the same thing. Order of operations counts. Let's see. 2x plus 3 and 4x minus 1. What's f of x? What's g of g? What's f of g and what's g of f? So different compositions. F of f is f of x. It's f of 2x plus 3. So twice 2x plus 3, that plus 3. After a bit of arithmetic, you get 4x plus 9. G of x is g of x. That's g of 4x minus 1. So that's 4 times 4x minus 1. That minus 1. After some distributing and combining, you get 16x minus 5. F of g of x is f of 4x minus 1. So that's twice 4x minus 1 plus 3. After a bit of arithmetic, you get 8x plus 1. G of f of x is g of 2x plus 3. That's 4 times 2x plus 3 minus 1. And that comes out to 8x plus 11. Again, not the same. Here we have f of x equals x minus 1. G of x equals root x. H of x equals x minus 1 also. What's f of g of x? F of g of h, what is that? Well, it's f of g of h of x. Well, h of x is x minus 1. So it's f of g of x minus 1. G of something is root of that thing, so you get f of root of x minus 1. F of that thing is that thing minus 1. So root of x minus 1, all that minus 1, and we're done.